This lesson is on radian measure and angles on the Cartesian plane. So one of our big things that we've learned, a little kind of formula to keep in mind, is that 180 degrees is equal to pi radians. So let's look at the chart first. 360 degrees, I want to convert that to radians. Remember what we do? We do that trick where we multiply by 1. And here's our 1. It's pi over 180. So we cancel some stuff out and we're left with 2 pi. That means that 360 degrees is equal to 2 pi. And just to give you a visual of that for our sketch, if I'm starting at the positive x-axis, which is here, that's the positive x-axis, and I rotate around counterclockwise, keep going all the way around, this is 360 degrees all the way back to where I started from. So that's 360 degrees. That's the same as 2 pi. We used to label this as 0 or 360, but we can now call it 2 pi. That's a rotation of 2 pi. Next one is 45 degrees. 45 degrees is the same as pi over 4 after you do your conversion, and pi over 4 is, well, it's 45 degrees, it's a quarter of the way. So an easy way that I always, one quick thing I always do each time is looking at my formula over here, this formula. That means this is pi right here on the left side of my x-axis. That's pi instead of 180. So sometimes I put that there to help me. Then I know 90 degrees, instead of 90 degrees, that's really pi over 2 because that's halfway to pi. Those two can really help me see where my angle goes. So if I'm trying to get used to converting into radians and not always thinking in degrees all the time, 45 degrees, I know where that is. I want to get a little bit better at thinking of pi over 4 on its own without converting back and forth. So for that, if I know pi over 2 is halfway, is straight up the y-axis, then pi over 4 is going to be from the positive x-axis, it's going to be split through the middle there, a quarter of the way over to pi. So that rotation there is pi over 4. That's my terminal arm, it's pi over 4. 60 degrees. 60 degrees, I multiply by pi over 180 and I get pi over 3. So again, pi over 3, think of your left side of the x-axis as being pi. That means that if I divided this up into thirds, this would be 1/3 of pi, this would be 2/3 of pi, and pi is the same as 3 pi over 3. That's the same as pi. So if I think of it that way, this portion at the top, the terminal arm is pi over 3, the next one is 2 pi over 3. So what I'm looking for, pi over 3 is, I didn't draw them perfectly, I didn't measure them, but pi over 3 is about here. The next one is pi over 6. 30 degrees, I jumped ahead, it's pi over 6. So again, what I'm going to do this time, on the left-hand side of my x-axis, that's pi. But I look at the denominator here, I have a 6, so I'm going to put that over a 6. So pi is the same as 6 pi over 6. That's the same as pi. So that tells me now if I divided up the top two quadrants into sixths, I would have 6 pi over 6. So halfway, right up to the top, which is pi over 2, well, that would be 1/6, 2/6. That should be a straight line. That would be 3/6, 4/6, and 5/6, and then 6/6. So this is pi over 6. So you kind of get a bit of a handle on your fractions here. You're dividing everything up into whatever the denominator is, sixths or thirds or quarters. So we're trying to think of dividing the top half of our Cartesian plane into that amount. So pi over 6 is from the positive x-axis. It's just 1/6 of the way around. The next one is 270 degrees. I convert that to radians. It's 3 pi over 2. So now I'm writing everything, I'm thinking of my 180 over here as pi, but I want the denominator to match this denominator. So I'm going to put a 2 over 2 here because that's the same as pi. They would cancel out and leave me with pi. 2 pi over 2. So pi over 2, I'm just going to, all I need to do is divide that into, 3 pi over 2. I'm going to divide everything into pi over 2s. So We already know 90 degrees is pi over 2. Let me change colors here. So there's 90 degrees, that's pi over 2. There's another 90 degrees, that's 2 pi over 2. Another 90 degrees would be 3 pi over 2. So 3 pi over 2 is, there's your positive x-axis, rotating all around here. That's your 3 pi over 2. So there at the bottom is your terminal arm for 3 pi over 2. Next one is 90 degrees. Converting that to radians, 90 degrees is pi over 2, and I've mentioned that pretty much on every single one we've done so far. So I'm just going to show my initial arm here, rotate up to my terminal arm here. 90 degrees is pi over 2, so pi over 2 is at the top. I'm crowded in there, but that's at the top of the y-axis. That's pi over 2 or 90 degrees. Last one is 0. 0 is an easy one. 0 is the same as 0 pi, so I'm not going anywhere for 0 pi. I'm just going to draw a line along my positive x-axis. So my initial arm, my initial arm is the same thing as my terminal arm. That's my 0 degrees or my 0 pi, the same thing there. So looking over to the side, we have a question for what values of theta. Now theta can only be between 0 and 2 pi. Are tan theta and cotan theta undefined? So right now we've just talked about degree measurements. We haven't talked about sine, cos, or tan of any of these things, right? We haven't even got those operators in there yet, those functions. We're just talking about the degrees themselves. So some of these degrees for sine, cos, or tan, or cotan, will be undefined. So let's figure out where they are. All right, so yeah, we haven't done much work with tan or cotan graphs, but if you can picture them, they have asymptotes, which is why we're going to have undefined parts. We're going to have vertical asymptotes in those graphs. We really have only concentrated on graphing sine and cosine so far, which have no vertical asymptotes. They're continuous. These ones are not. So we have parts where they're undefined. So where are they undefined? So I'm going to write it here. This space is a little more roomy for me. We know that tan theta is equal to y over x. That's another way of saying opposite over adjacent. So if we want to know when it's undefined, when tan is undefined, undefined means we have a denominator of 0. That gives us undefined. So when, in this case, when will our denominator, when will x be 0? That's what we're looking for. We're trying to find out when is, or where is x equal to 0? Because when that happens, our tan will be undefined. Now that 0 does not mean 0 degrees. The degree, or the radian, is the number that's going to go in the theta spot. That's where the degree, we would sub in 50 degrees there, or a pi over 7 there. That's not what we're looking for. We're not looking for an angle. We're looking for a measurement of a side, of a triangle, really. So think about your, let's do another x and y axis here. X and y axis, there. We're looking for where is x equal to 0. So x is equal to 0 on the y-axis. Anywhere on the y-axis, the x value is 0. So if I have a unit circle on here, let me draw somewhat of a circle. Anywhere that my circle touches the y-axis, I'm going to have a x value of 0. So the coordinate right here would be 0, 1. The coordinate down here would be 0, -1. So those have x values of 0. So what is the degree? Now we need to talk about the rotation. We'll talk about degrees first because that's what you're more comfortable with, then we'll go to radians. So this point right here, I'm putting a blue dot there. That coordinate right there, what is the rotation to the y-axis? What is the rotation there? So in degrees, that would be 90 degrees. But we're working in radians now, and the question, look at the question here, this is telling you you must give the answer in radians. That's the domain you were given. So 90 degrees is the same as pi over 2. So if your calculator is in radian mode and you put in 10 of pi over 2, it's going, different calculators will say different things. Probably won't say undefined, but it might say error, math error, or something like that. That's one answer. What about the other answer? The other answer is down here on the circle. So I want to rotate this time all the way around to this part of the y-axis. What is that rotation? In degrees, you know that's 270 degrees, but we're trying to work our way into radians now. 270 degrees is 3 pi over 2. So when we're looking at pi over 2 or 3 pi over 2, in both of those cases, the x value is 0. And when our x value is 0, right here, we are going to have an undefined answer because our denominator is 0. So that's tan we're talking about. So let me just kind of summarize that here. So the next part of the question is, when is cotan theta undefined? So cotan theta is undefined. Same thing, we need the denominator to be 0, but let's talk about cotan. Cotan is not y over x. Cotan is x over y. We want our denominator to be 0. We want y to equal 0. Let's do another Cartesian plane sketch here. Here's our x-axis. Here's our y-axis. We want a y of 0. Let me put a circle on there. When will y be equal to 0? So y will equal 0 anywhere along the x-axis. So anywhere along the x-axis, the y value is 0. So now what you have to figure out is, what are the rotations or the degrees or the angles here? Well, let's do the first one here, where I'm putting the first dot. What the coordinate there is 1, 0. Now what is the rotation there? In radians or degrees, you're going to get the same thing. It's going to be 0. So that one is 0 degrees, which is the same as 0 radians. So we'll just leave it as 0. You don't have to put a pi beside it because 0 times pi is going to be 0 anyway. So you can just leave it 0, but 0 pi. That's one. Is there any place else that we have a y value of 0? Yes. All the way over here on the left of the circle, at the negative x-axis, right here, the coordinate there is -1, 0. Again, I have a y value of 0. The rotation to that spot, so that's 180 degrees, but we're converting that to radians now. 180 degrees is the same as pi. There's one more answer, just because the 0, 1 always has two answers. So we rotate around all the way back here to 360 degrees. And that's the same as 2 pi. The reason we need both, even these two, the first and the last are in the same place, that's because our domain says we have to, it's 0 less than or equal to pi, or theta less than or equal to 2 pi, it's less than or equal to, right? See this symbol here and the symbol here, we have to include 0 and 2 pi, so that's why we have that repetition there. So those are the three values in radians where cotan theta is undefined. Example 1, determine the exact value of tan 7 pi over 6. So I've put back up here our special triangles. This would be our 45 degree, this is our 45 degree triangle, this is our 30 degree and our 60 degree. So we're hopefully slowly moving over into working with radians and not just with degrees all the time. And then these are the unit circle values here. Exact value of tan 7 pi over 6. So first of all, I put a little x and y axis. I always do this. You don't have to, but I think it really helps to see where we're going. Where is 7 pi over 6? So a lot of us right now are going to say, you know what, I'm just going to convert that to degrees and then I know where it is. I'm going to convert it to degrees. But let's just try not converting it to degrees here. 7 pi over 6. Remember what I showed you before. I'm going to take the denominator, which is a 6, and over here on the left-hand side of my x-axis, which is normally pi, that's the same as 180, I'm going to write that with the numerator and the denominator of 6. So 6 pi over 6. That means up at the 90 degree, we would have half of that. That would be 3 pi over 6, which is the same as pi over 2. On the right-hand side, we would have 0, but when we get all the way around, it would be 12 pi over 6. So I'm just converting everything into sixths here. And then 9 pi over 6. So just some good practice with our fractions here. So converting everything into sixths. So 3 pi over 6, I'm going to put 3, there's pi, let's say that's 1/6. That would be pi over 6. 2/6. And then we've got 3/6 as the next one. There's 4/6, 5/6, and then we're at 6/6 again. And then here is what we're looking for, 7 pi over 6. There's 7 pi over 6. And it's okay if right now what you're doing is converting to degrees and drawing it, because this part's too overwhelming for you, but you will get there. Well, you won't have to do all that conversion all the time. But for now, we've got a rotation here. Here's an initial arm on the positive x-axis, rotating all the way around to this line here. That is 7 pi over 6, that black curve that I just drew. So now we know what quadrant we're in. So that triangle here, I'm going to turn that into a 90-degree triangle like this. Like a straight line there, going all the way across. There's a 90-degree triangle. That's your 90-degree, or if you're getting better with this, then you're thinking of it as pi over 2. The little beta in the corner, this little piece, this little sliver, this little angle right here, what does that little angle measure in radians? It's pi over 6. Remember, each of these little slivers between each two yellow lines, or the yellow and the black line, they're each a sixth. So that little piece right in there is pi over 6. So that little, I'll use a different color here because it's pretty crowded. I'm just going to put an arrow like that. That piece in there is pi over 6. So I've got a pi over 6 triangle. I look up to my special triangle, and again, you could be doing all this in degrees. It's okay, but let's work on radians. So I've got a pi over 6 triangle, which is a 30 degree. So I'm going to label my sides, my opposite the pi over 6. I've got, so opposite the pi over 6 is a 1. The hypotenuse is 2. And the other side is a root 3. So we've got some negative values here. The x value is a negative and the y value is a negative because it's gone down. It's in that third quadrant. So tan of 7 pi over 6. Tan of 7 pi over 6. So if you want, you can remember that tan is opposite over adjacent. So looking back to the triangle here, here's my pi over 6. My opposite is right here. That's a negative 1 is my opposite. My adjacent is a negative root 3. So that's the same as negative 1 over negative root 3. And two negatives, of course, make a positive, but I also have to rationalize my denominator. I can't leave it like that. So I'm going to multiply by root 3 over root 3. That will give me, the negatives, remember, they're canceled out now. So on my numerator, I'll have a root 3. And on my denominator, I'm going to have root 3 times root 3, which is root 9. Okay, I'll write it down there, root 9, which is really, move it up here, root 3 over 3. So a lot of your calculators will give you that. You can type that all in radians. You could put this whole question in radians, and it will give you this lovely answer right here, and it will be all rationalized. It'll look beautiful. That's why we have non-calculator quizzes and non-calculator tests in this unit, because I don't care what your calculator can do. I need to know what you can do. So yeah, your calculator can do it all for you, but you need to be able to do it without your calculator. So that's the first one. Let's take a look at the next one. Secant of 3 pi over 4. Okay, 3 pi over 4. Where is that? So let me do some labeling here. I'm going to use my denominator, which is a 4, and I'm going to go to my pi and change it to 4 pi over 4. That's the same thing as pi, which is 180. Those are the same. So 4 pi over 4. That means 90 degrees would be half of that. That would be 2 pi over 4. And then this is a 0. So 0, 2 pi over 4. Let's draw the lines in here. We've got 1 pi over 4 is this first line. That's pi over 4. Pi over 4 is my first one. Then the next one is 2 pi over 4, 3 pi over 4, and all the way across the bottom is 4 pi over 4. We want 3 pi over 4. Okay, sorry about that. Secant of 3 pi over 4. So we've divided this up into fourths. Secant of 3 pi over 4. So secant, remember what that is in terms of x, y, and r, or opposite, adjacent, hypotenuse, all that. So secant is r over x, where r is the hypotenuse and x is the adjacent. So you could think of it like that too. So what does that mean? Let's take a look at our 3 pi over 4 arm. Here's our terminal arm for 3 pi over 4. So I'm going to draw a triangle right down here. We're going to create a right angle triangle coming down to the x-axis. And this angle in here, this is my beta. This is my related acute there. So my beta angle is a fourth, right? This is a pi over 4. So my beta angle is pi over 4. So I go up to my triangle, my pi over 4 triangle here. And I'm going to use these side measures to label my triangle. My hypotenuse or my radius is √2, and my adjacent and opposite, my x and my y's, are both 1s. So this, anything negative here, the x here is a -1. So when I substitute that into my, up here on the top right, I substituted in my r, my radius is a √2. Now radius can never be, hypotenuse can never be negative, so that's always positive. But my x is 1, and it is on the left-hand side of the y-axis, so it is a -1. So I'm just going to rewrite that as -√2. So secant of 3 pi over 4 is -√2. Example 3, state an equivalent expression based on a related angle for cosecant 4 pi over 3. What are we talking about? Okay, let's start with this. Cosecant 4 pi over 3. Where is that? 4 pi over 3. So 4 pi over 3 means we're going to divide everything up into thirds. I'm going to go over to my x-axis here. This is pi, which is 3 pi over 3. So I'm dividing this into thirds. There's 1 pi over 3, there's 2 pi over 3, and then 3 pi over 3. So 4 pi over 3 is the next one down. That's 4 pi over 3. This would be 5 pi over 3. That would be 5 pi over 3. And then all the way back would be 6 pi over 3, which is 2 pi. So we only need to find 4 pi over 3. This one right here is 4 pi over 3. 1, 2, 3. So we don't actually use the axes on these because we're dividing it into thirds, not into halves or quarters. So for the pi over 3, we don't use the axes as one of our terminal arms. So our 4 pi over 3 is right here. 4 pi over 3. Okay, that is our positive x-axis. There's our terminal arm. There's our rotation. That's 4 pi over 3 in red. Now, the question is saying state an equivalent expression. So it's not saying what is 4 pi over 3. It's not saying, oh, is that √2 over 3. It's not asking what the output is, what the answer is. It just wants to know what else would give you the same answer. What's another way to get the same answer as cosecant 4 pi over 3? So cosecant in the third quadrant, so let me label the quadrants here. Quadrant 1, 2, always uppercase Roman numerals, quadrant 3, and quadrant 4. In quadrant 3, cosecant is what? Is it positive or negative? Let's get the cast rule on there. C-A-S-T. So we're looking in the third quadrant. Tan is positive or cotan is positive. That must mean cosecant is negative. So we've got part of our answer. So we know our answer is going to be negative because the quadrant that we're in is negative. Cosecant, remember, is the reciprocal of sine. So sine is negative there, so cosecant is negative there too. Where else is cosecant negative? We want to get the same. Let's say I'm going to make up an answer here because I don't want you to think about the actual output. Let's say the answer here is negative 25, which it is not. I want to find out how else could I get the same answer, negative 25. So I need it to be negative. So this is the important part here, is the negative. Where else is cosecant negative? Where else could we get an equivalent answer? So where else is cosecant negative? So cosecant is also negative in what quadrant? Quadrant 4. Quadrant 4. It is negative because of the cast rule. The only thing positive in quadrant 4 is cos. So that would mean cos or secant. So cosecant and sine, they go together. So they're going to have the same, they're going to follow the cast rule the same way. So now what I have to figure out is in quadrant 4, so cosecant negative in quadrant 4. So I look at my 4 pi over 3. My related acute, what was my related acute here? My beta angle right here in the corner, in the vertex of the origin right here. That's my related acute. That's the beta angle. What does that measure? So that's just the denominator. That's a third. It's going to be pi over 3. So my beta angle is pi over 3. Remember, I divided everything up into thirds. So here we had 1/3, 2/3, 3/3. So in quadrant, or sorry, 3/3 is here. 4/3, 5/3 is here. So this arm right here is going to be my other answer. That means cosecant of 4 pi over 3 is equal to cosecant of 5 pi over 3. And you can check that on your calculator. You would have to use sine, you would have to reciprocate everything, but you would get the same answer. Cosecant 4 pi over 3 is an equivalent expression to cosecant 5 pi over 3. Again, you can be converting all of these to degrees if you want to, and then coming back to radians later, and eventually, you know, it's like learning any new language. We translate everything, and then at some point we can throw in the words of the other language without having to translate all the time. So we're hoping to get there. And this is a long lesson. We're about halfway through, so if you want to pause or take a break now, you can, and then we'll continue with example 3. Example 3. For each of the following values of tan theta, determine the measures of theta. So this time we're given the output, we're given the answer, and we have to go backwards and figure out the rotation. So tan theta, first one is tan theta equals -1. So that's what the question is saying. We've got tan theta, we don't know what theta is, but we know the output is -1. How are we going to find a value for theta? So tan, remember, is y over x. So we need y over x to get to be a -1. So that the only way to get a -1 is like a 1 over 1. And the negative is going to go either in the numerator or the denominator, one or the other, not both. So we have to figure that out. So can you think of one of your special triangles that has, and if you don't like the y over x, you can think of opposite over adjacent. What triangle has an opposite of 1 and an adjacent of 1? So let me just draw a little sketch here. Let's say this is theta in the corner. The bottom corner here is theta. The opposite is over here. I need that to be a 1. The adjacent needs to be a 1. What triangle is that? And if you're thinking of degrees, maybe you're thinking of 45 degrees, which is pi over 4. So you can do the whole question in degrees if you want to, but look at the question up here in the top right. The answer has to be in radians, has to be because of that. So if you want to do it in degrees, you can, but let's work through this in radians. So our theta is going to be, for the triangle I drew, is pi over 4. But opposite over adjacent here is going to give me a positive 1 over 1. So now the next thing I need to think about are the quadrants. Because tan is not negative, I'm going to turn this into an x and y axis here. So in quadrant 1, that's where the triangle I drew originally is in quadrant 1. Let me move my axis over here. Should be coming right through the vertex there. So in quadrant 1, tan is positive. Castrol C A S T. We want tan to be negative. Where is tan negative? Tan is negative here and here. So we've got to take our pi over 4, or 45 degree. We've got to put a 45 degree angle here, and we've got to put a 45 degree angle here. So we'll call this first one over here theta 1. So right here, I'm going to draw another terminal arm there. That rotation is our theta 1. So theta 1, what does that measure? What I drew in orange there. So the acute angle, I'll draw the acute angle here. That's a pi over 4, or 45 degrees. So that angle that I drew is 180, or pi minus pi over 4. That's what our theta 1 is. So that's 4, which can't make our denominators match, 4 pi over 4. So think of pi as x. So it's like saying 4x over 4 minus x over 4. That's going to give you 3 pi over 4. So that's our first answer, theta 1. Theta 2, so remember we want tan to be negative. It's got to be negative down here. So I'm going to draw another terminal arm. So this terminal arm is coming all the way around here. So that's theta 2. Theta 2, if we continued all the way back to the x-axis, we'd be at 2 pi, but we are pi over 4 short of that. So that's 8 pi over 4 minus pi over 4. That's 7 pi over 4. So that's our theta 2 is 7 pi over 4. So what we've got is tan of 3 pi over 4 is equivalent to tan of 7 pi over 4, and that's all equal to -1. That's what we've found there. Let's try that again. This time we've got a -√3. So tan theta, this time we're looking for tan theta equals -√3. So let's figure this out again. We need, let's put an invisible 1 under that there. That's an invisible 1. What triangle gives you an opposite of √3, forget about the negative, and an adjacent of 1? Let's see, draw a little sketch here. Forget about the negative, so I'm just going to put my triangle here. It's not a very good triangle. Fix this line. That's not much better. Okay, so I want, if this is theta right here in the corner, I need an opposite of √3 and an adjacent of 1. Opposite adjacent of 1. What triangle is that? So that, if you know your special triangles, the hypotenuse is 2. And what is theta in this diagram? What triangle is this? This is your 60 degree or your pi over 3. So pi over 3, theta is pi over 3, but we've got to put our quadrants in here. Let me turn that into a Cartesian plane, x and y axis. We had a negative in the question here, negative. So the answer cannot be, theta cannot be just pi over 3, because pi over 3 is positive. Tan is positive in that quadrant, so we can't have that answer. So where is tan negative? Tan is negative, Castrol, C-A-S-T. t. Where is tan negative? Same as the last question. Tan is negative in quadrant 4 and quadrant 2. So I take my pi over 3 angle and I put it up here. That's pi over 3. So this rotation to here is my theta 1. That's theta 1. That's the first option we have. Will give me a negative tan. So theta 1 is equal to 2 pi over 3. And theta 2 is down here. So again, we take, it's like we're picking up this triangle right here. I'm picking up this triangle and I'm putting it in this quadrant. That will give me my negative tan. So this angle, put it down here. When I do that, if I draw that triangle down here, there's my pi over 3. There's my root 3, which is now a negative root 3. There's still my 1. So that's how I'm getting my negative tan, because I've put it in that quadrant. So what is the rotation all the way around to this terminal arm? If I went all the way to the end, if I rotated all the way around, I would be at 2 pi. But I'm pi over 3 short of that. So I'm a third short of 2 pi. So that 2 pi over 3 is the same as theta 2 is 2 pi minus pi over 3. 2 pi, and we want to use thirds, right? Because we want a common denominator. That's 6 pi over 3 minus 3 pi over 3. Pi over 3, we get 5 pi over 3. So those are our two answers, theta 1 and theta 2. Those will both give us with tan the equivalent answer of the exact same answer of negative root 3. Example 4. Negative 8, 1 is located on the terminal arm of an angle in standard position. Let's start with that. Negative 8, 1. So I've put little x and y axis here. Let's say negative 8 is here, there's negative 8, and 1 is here. So negative 8, move that down. Negative 8, 1 is right there. There's negative 8, 1. Negative 8, 1 is on a terminal arm, okay? Terminal arm, so I should be using a ruler, but it's pretty hard with this tablet to use a ruler, and I'm going to try to draw a line between the vertex, the origin, and that dot. So there's our negative 8, 1, and it's on this terminal arm here of an angle in standard position. Standard position means from the positive x-axis we rotate over. So there's my positive x-axis rotating over. That means it's an angle in standard position. And that's what the question is telling us we're going to call theta. So that's theta there. Find the measure of that angle theta. So I could turn this into a triangle here, but I don't have a triangle for this. So I have this side here is a 1 on the left. The y value is a 1. The x value along the bottom is negative 8. I don't have a triangle with those measurements on it. So what I'm going to do to find some more information is I'm going to do a little bit of extra work. You wouldn't have to do all of this work for the question, but I'm going to find r. So I know x is negative 8. I know y is 1. How would I get r? How would I get the radius or the hypotenuse? So the radius is here. Pythagorean theorem, I hope, is what you're thinking. Pythagorean theorem. X squared plus y squared equals r squared. Let's sub in. Now this question isn't asking us for r, but you will have some in your homework that will, so I'm going to go over it anyway. 64 and 1 is r squared. So we get the square root of 65 is r, and that's an exact value. So I'm not going to get out my calculator. I'm just going to leave it as the square root of 65. That's my radius. Again, that's not needed for the question. The question just wants us to find the measure of the angle. So I have, out of sine, cos, tan, cosecant, secant, cotan, I have one that just uses x and y. That's why I didn't really need r. Sine, cos, tan, which one uses just these numbers? And then I don't need this. I know what you're all saying. It's tan. Yes, tan. So tan is y over x. So we've got tan theta equals, and my y value is a whoops, that's supposed to be a 1 over -8, or we're just going to move that negative up because we shouldn't have the negative in the denominator. You can put it in the middle, or you can put it on the numerator, -1/8. Now we can use our calculator. And the question says here nearest hundredth, so that's your key right there, that you're allowed to use a calculator. So in your calculator, make sure your calculator is in radian mode. Some calculators, every time they shut off, will default back to degree mode. So please make sure your calculator is in radian mode. So what you're going to actually put into your calculator, theta is equal to tan inverse of -1/8. That goes into your calculator. And what do you get? Okay, you probably get theta equals -0.12. What does that mean? Theta equals -0.12. Okay, let's get a visual on that one here. Over to a x and y axis. So we know this is 0. Up to the top of the y-axis there, that's 90 degrees, which we now know is pi over 2. So with your calculator, if you do pi divided by 2, 3.14 divided by 2, you're going to get up top here, I'm going to write it in decimals, only because this question is in decimals. I'm going to put 1.57 instead of putting pi over 2. Over at the other side of the x-axis, that's normally a pi. But that is, of course, 3.14. Down at the bottom of the y-axis, that's 270 degrees, which is also 3 pi over 2. So 3 pi over 2 is 4.71. I'm converting to decimal because the question is asking for decimals. So now let's go back to what we got here. We got, our answer we got is theta equals -0.12. The negative is telling me this is not standard position. My calculator is not giving me the correct rotation. It's not rotating around this way. It's rotating around this way. That's what the negative is telling me. It's rotating this way. So it's rotating that way, 0.12 of a radian. So all the way to here would be 4.7 radians. I'm just going 0.12. So I have a little wee line right there. I'm just going to draw a little, I can't even put one small enough there, but a little very small angle in here. That angle is what my calculator told me. That's my 0.12. That's what I have here. That's that rotation, negative rotation, because we went the wrong way. Put a negative in front, sorry. That's my -0.12. So why did your calculator do that? Because your calculator knows that tan is negative in that quadrant. So your calculator gave you the smallest answer it could, but we can't have negative rotation. So let's see what the positive rotation of that would be. If I rotated this way, which is the right way, what's that in radians? So that we're going to have theta equals 2 pi minus 0.12. That would give me this theta here. I'm just going to call that, I'll just call it theta 1. That would be my theta 1. That would be my 0. So we subtract these two here, and so that 2 pi, so you're going to do 3.14 times 2, 6.28. I can put that over here. That's also 6.28. So I subtract 6.28, 0.12, and I'm getting 3.02. So we've got an answer to the nearest hundredth of a radian, but we've got a problem here. I'm wondering if any of you noticed this as I was doing the question. The original question said -8,1. That's way over here. I just gave you an answer in the wrong quadrant. And I did that because my calculator gave me negative 0.12. So I drew that in the proper quadrant. I got the rotation, 3.02. But that's not the answer. The question specifically said we have to get the rotation to negative 8.1. This is theta right here. So our calculator did two things that confused us. One was it gave us a negative rotation. The other is it put it in the wrong quadrant. But tan is negative in this quadrant and in this quadrant. So I just have to take my little light blue value here, and I'm going to put it where it belongs in quadrant 2. So there's my negative, there's my 0.12 right there. That's this piece. And that's really what I'm looking for. That's my theta right there. So my theta is really, so I'm just going to write this down here, not in quadrant 4. We are in quadrant 2. We're in quadrant 2. So what we really want, oh, I gave you that answer up there. Sorry, I jumped ahead. This wasn't supposed to be 3.02. This is my answer here is 3.02. Let me fix that. I really hate it when I do that because I don't want to go back and redo the whole question. So sorry, I probably confused a lot of you there. I was explaining it correctly, but then the answer I wrote down was not. So it was 6.16 is this theta 1 is 6.16 up here. I want 3.02. I want pi minus, let me change that. So in quadrant 2, what we want is pi subtract 0.12. There's our 3.02. That's the answer that we want. Sorry. There we go. Put a little happy face. Maybe that'll make you feel better. So let me just recap that there in case I threw everybody off. We started off with our quadrant or our coordinate here, negative 8.1. I did this extra piece here, finding the radius or the hypotenuse, which we didn't need, but you will for some of your other questions. So that's kind of an aside right here. Went back to the question. I realized that since I knew the x and I knew the y, I decided to use tan because tan is the trigonometric ratio that uses the y and the x. Substitute them in for y and x, and then I used my calculator in radians, and my calculator gave me 0.12. So it gave me two things that weren't helpful. One was it gave me a negative rotation, which is this blue arrow going down, a negative rotation, which we're always supposed to give positive rotations. That's our domain is telling us that. We can't have, there's no negatives here. The other thing is that it gave us an answer in quadrant 4, which isn't helpful because clearly negative 8.1 is in quadrant 2. So in quadrant 1, we would get 2 pi minus 0.12. We would get 6.16, but that's not the right answer because we're not in quadrant 4. So none of this even matters. We want quadrant 2. Quadrant 2 is pi minus 0.12, 3.02. That's example 4. We're not done yet. If you haven't taken a break yet, maybe now is a good time because we've got a little bit more to go. Example 5, a signpost with a length of 2 meters is stuck in the ground, so maybe a car hit it. See this sign over here? It's an obtuse angle. Let's get a little diagram here. We've got a lot of information, so let's put it into a diagram. You should really use a ruler. I'll try, but it's always a mess. When I'm using a Wacom tablet here, and it recognizes the ruler and it throws my pen off, but let me give it a shot. So that line is the ground. We'll say that's the ground, and then I have to put in the signpost at an angle. Well, I'm not going to measure the angle. I'm just going to draw in the signpost. Okay, let's say that's the signpost there. So the post is 2 meters there. And here's the obtuse angle. Obtuse means greater than 90 degrees. So my obtuse angle is this one here. That's the obtuse angle. That's theta. And the tip of the signpost is 0.6 meters above the ground. So the tip of the signpost is out here. That is 0.6 meters above the ground. Finish off my triangle there. That's 0.6 meters above the ground. and determine the obtuse angle in radians that the sine post makes with the ground. So I need to find theta. But I have to first work with my related acute. I'm going to have to work with the beta angle first. So the beta angle is this one in here. I'll write that down. This is beta. I'm going to find my beta angle first. And that's always it's generally the Greek letter we use for a related acute. It means it's related to your theta in some way, but it's acute, right? The question asks for an obtuse. You usually have to work with an acute first. And theta is the principal angle. That's the principal angle. And that's always measured from a positive x-axis. So that's just some terminology. Okay, look at what we've got here. We've got a, for the beta angle, I've got a right angle, which is great. Right angle means sine, cos, or tan. So across from the right angle, that's my opposite. I've got a 0.6, and I've got a hypotenuse. Sine, cos, or tan, which one uses an opposite and a hypotenuse? You remember that from grade 10. We're going to use sine, and I'm putting a beta there. Sine of beta, so that's opposite over hypotenuse. Let's sub in some stuff here. Beta, I don't know what that is, but my opposite is 0.6. My hypotenuse is 2, so we definitely need our calculator, especially when it says hundredth, right? That's telling you decimals. You do inverse sine of 0.6 over 2, and your beta angle is 0.3. It says hundredth, so I put a 0 there, 0.30. But we need to find theta. To find theta, what are we going to do to find theta? Well, if we had measured all the way from the positive x-axis here all the way across, that would have been 180 degrees, or, everyone knows this now, pi. So we're a little bit short of that, so I got to back up my arrow back this far, right? I'm not actually doing 180 degrees, I'm 180 minus this piece here. So to find theta, theta is going to equal pi subtract our beta angle, 0.30. 0.30. So our theta angle is 2.84, and that is, of course, in radians, not in degrees. So a sentence always at the end of a word problem. Therefore, the obtuse angle is 2.84 radians. And obtuse, just in case you forgot what that means, obtuse means it's between 90 and 180 degrees. Okay. In a question like this, normally most people, if you ask them about in the real world the angle of a stop sign, you're not going to answer them in radians. You're going to answer in degrees, but we're practicing here. So obtuse angle is between 90 and 180 degrees. So if the question says obtuse, you make sure you're picking the right angle, not the beta, not the acute, but the obtuse is here. Next question. Last slide. Okay, we're almost done. Example 6. The needle of a compass is 4 centimeters in length. So here's a compass. And the tip of the needle is 3.8 centimeters below the line pointing east. Let's go over to my little Cartesian plane here. That's the title of today's lesson, right? It's all about Cartesian planes, and I'm going to label it north, south, there's west, and there's east. And I've got a needle of a compass, and it's below the line pointing east. So I'm going to just draw a line like that. There's my needle of the compass, and it's 4 centimeters long. And it's 3.8 centimeters below that line pointing east. So that's 3.8. So we have right angle triangle. Wonderful. Now the other part of the question says, determine the acute angle in radians that the line pointing east makes with the needle. So that means we're actually doing a negative rotation. We're going from the line pointing east to the needle, the acute angle. So we're going to have to get a negative. I'm going to put this, so this is my theta here, and it's the same as the beta in this case, but it's going to be negative. This is the first time we've had a negative. So looking at that angle theta, here's my angle, here's my triangle. I've got an opposite and I've got a hypotenuse. So what are we going to use? Opposite, hypotenuse, sine. Sine theta equals our opposite is 3.8, but it's a negative because it's gone down, right? It's below the x-axis. Our hypotenuse is always positive, 4. You put that into your calculator, you'll get theta equals negative 1.25. And we expected the negative because of the way the question was worded. We were looking for a negative rotation. So our acute angle is negative since it's measured from the positive x-axis counterclockwise. So we have a negative answer, and that's what we expect. So we're just going to put a little sentence for this. Therefore, the angle is negative 1.25 radians. So that was a pretty quick one. I just wanted to throw that in there because of the negative. That was our last example, but I often find students have a hard time with this question that's in the homework. So we're going to start it off together. Find the sine of the angle formed by two rays. What's a ray? It's a portion of a line which starts at a point and goes off in one direction to infinity. So basically a line that has an arrow at one side and not at the other side. So this is a ray right here. So the weird part is one ray passes through this point, 3√3, 3. Okay, this is fine. My y value of 3, I know that one. This one I don't really know, but I don't really care exactly what 3√3 works out to be. What I do need to look at is that it's positive. So I've got a positive x value and a positive y value. That means that point is going to be my first quadrant. So there's my y value of 3. I'm putting it, labeling it here. My x value is 3√3. I don't really know where that is. It doesn't matter. This sketch is just to help me. It's not asking me to draw an accurate diagram. So my point, 3√3, 3, is right about here. Right about there. So I'm going to draw a ray through that point. So there's my ray, and it's passing through that point and the origin. Okay, I put it in yellow because it makes me always, that's how I remember sun's rays. Like a sun's rays, or the origin is the sun and they come out from the sun, so that's a ray. The other ray passes through negative 4, 4√3. So that's an x value of negative 4, so it's going to be over here somewhere, negative 4, and 4√3. I don't really know where 4√3 is, but it's positive. It's probably higher than 3. So I'm going to put that point maybe about here. Okay, I'm not going to label this one, but well, I'll put the negative 4 on. Now this is not to scale. This is not where negative 4 would be with respect to where 3√3 is. So negative 4 and 4√3, let's say that's up here somewhere. I'll put it right at the dot of where I have infinity. So we have another ray going through this dot. Let's pretend that's straight. So there's my other one. Now we have to find, let's look back to the question. It says find the sine of the angle formed by the two rays. So I'm looking for this angle right in here. That is my theta. How am I going to get that? I'm going to have to use the other angles here. Let me call this one alpha, and this one we'll call it beta. So I've got three angles here, and what I'm going to need to do, so let's look at the first one. I'm just going to draw a line, drop a perpendicular line down here. I'm talking about the alpha angle here, so I know that this is my y value. I know that that's a 3. I know that my x value is a 3√3, so out of sine, cosine, tan of alpha, we're going to use tan, because tan of any angle is y over x. So I've got tan of alpha is 3 over 3√3. And I can actually cancel out these 3's here. Just to simplify it a bit, tan of alpha is 1 over √3. Okay, so I can use inverse tan on my calculator and I can get the question says nearest hundredth, so I'm going to be able to use my calculator here to get an answer for tan. That will give me an answer for alpha, sorry, that'll give me an answer for alpha. Alpha equals, and you guys can finish that. I'll do the same thing on the other side, get an answer for beta. Beta equals, figure that out. And then what is theta? But the question actually asks for theta, this piece here. So how would you calculate theta? If you know alpha, let's go to degrees here, since we're just starting with radians. Let's say alpha is 20 degrees and beta is 40 degrees. What's theta going to be? Well, the whole thing is 180. So we would do 180 and we'd subtract these two to get alpha. So to get theta, sorry. So theta is going to be, okay, I'll write it in degrees first, but in degrees we would have 180 minus alpha minus beta. That will give us our theta. Just in this question, actually, it doesn't say you have to use radians during your calculation, and the answer isn't necessarily going to be in radians, so I'm not sure. It doesn't say radians here, so you could use degrees if you wanted to. Probably the back of the book is in radians, so you would change that 180 to a pi when you finish the question. So that's the end of today's lesson on radian measure and the Cartesian plane. So everything we were doing today, we were throwing it on an x and y axis to get an idea of where it was going. It's a long lesson, over an hour, a lot of material. Hopefully you took a break in there, and now you're ready to go and do some homework and practice the questions. Good luck.